next section we're going to talk about is solving inequalities using multiplication and division. And then textbook, this is section 2.3. So example 1 is multiplying or dividing by positive numbers. So example 1a is x over 8 is greater than negative 5. We want to solve this inequality and graph it. So x over 8 is the same thing as x divided by 8. So if my goal is to isolate the x, or to get x by itself, then in order to do so, I need to undo dividing by 8. So to undo dividing by 8, I can multiply both sides by 8. So multiplying by 8 and dividing by 8 undo each other. So they cancel each other out. I'm just left with x, and then my inequality symbol, so greater than, and then negative 5 times 8 is negative 40. And then on your number line, we can put negative 40 in the middle. And then sometimes when you have a negative part of the number line, you have to be a little bit careful. So as we go to the right, we're getting bigger, we're getting closer to 0 since we're below 0 right now. So if we go up 1, that would be negative 39. And then up 1 again would be negative 38. And then if I go down 1 from 40, it'd be negative 41. And down another would be negative 42. And then our inequality is x is greater than negative 40. So that means we need a open dot or open circle on the negative 40, and because our x is on the left side of the inequality, the point on the inequality should match the same direction as the point of our arrow. So our arrow should be going to the right. So x is greater than negative 40, so our arrow is covering all the numbers that are larger than negative 40. Anytime we're getting larger, then we're going to the right. So open circle on negative 40, arrow pointing to the right. And then for b, negative 24 is greater than or equal to 3x. So if our goal is to get x by itself, we have to undo multiplying by 3. So to undo multiplying by 3, I can divide by 3. Whatever I do to this side of the inequality, I need to also do to the other side. So multiplying by 3 and dividing by 3 cancel each other out. And then negative 24 divided by 3, that's negative 8, is greater than or equal to x. And here's where we have to be careful because our inequality is not facing the same direction as it was in the first example. So anytime you have a problem like this where the variable ends up on the right side, you kind of want to flip it over. You just have to make sure that the inequality stays pointing towards the same variable or number. So if I flip this over, I'm basically going to take this inequality and like mirror it almost. So the x will go on the left side, and originally the inequality was pointing towards the x, so I'm going to keep that the same. The inequality symbol will point towards the x, and then negative 8. So I just took this inequality and I flipped it over so that it started with the x, and the point stayed starting at the x, so I didn't actually change the value at all. So negative 8 will go in the middle of the number line, and then if I want to go up 1, that would be negative 7, up 1 again to negative 6. If I want to go down 1, be negative 9, down 1 again to negative 10. And the inequality symbol is x, or it's less than or equal to, so I'll have a closed dot on 8. And then if it's x can be less than or equal to to negative 8, then I need to go over all the numbers that are smaller than negative 8, or I need to go to the left. So when x is less than that number, or less than or equal to, we're going to the left. If it's greater than or equal to, we have to go to the right. And then for c, 1/3 x is less than 2. So we have 1/3 being multiplied by x. Usually to undo multiplication, we divide, but dividing by a fraction is kind of tricky sometimes. So if you ever have a fraction that's being multiplied by your variable, if you want to get your variable by itself, you can multiply both sides by what's called the reciprocal. That's basically the fraction taken and flipped upside down. So if I want to cancel out multiplying by 1/3, I can multiply both sides by the reciprocal by 3 over 1. I multiply this side by 3 over 1, I need to multiply this side by 3 over 1. So multiplying 3 over 1 by 1 over 3, those just cancel each other out, everything cross cancels. And I'm just left with x is less than. And then this is 2 or 2 over 1 if you want to think of it that way. So 2 times 3 is 6. And then 1 times 1 is just 1, but anytime you have the fraction where the denominator is 1, you don't need to include that part because it's the same thing as just 6. So 6 will go in the middle of our number line, up to 7, 8, and then down to 5, 4. So x is less than 6, we need an open circle on 6. And if x is less than 6, our arrow should be pointing to the left because all the numbers that are less than 6 are on the left side of it. So 5, 4, 3, all the way down to 0 and to the negative numbers. So example 2 is multiplying or dividing by negative numbers. So the first 3 problems up here, we multiplied or divided only by positive, like positive 8, 3, 3 over 1. But now we're going to multiply or divide by a negative number, and there's something very important that you have to remember when we're multiplying or dividing by negative numbers when solving inequalities, and that's that you have to flip the inequality symbol. So first example is 2 is less than x divided by negative 3. So if I want to undo dividing by negative 3, I know I need to multiply both sides by negative 3. So negative 3 times 2 is negative 6, and then because I multiplied by a negative number, I need to flip the direction of this inequality symbol. So it was pointing to the left, I need to flip it so that it points to the right. So it started pointing to the left, I'm going to flip it so it points to the right, and then multiplying by negative 3 and dividing by negative 3, those cancel each other out, and you're just left with x. But now we have an inequality where the variable's on the right side, and I want the variable to be on the left side. So I'm going to take this inequality and I'm just going to flip it over. So the x will go on the left, and I just have to make sure that my inequality symbol stays pointing at the same thing. So it was originally pointing at the x. I'm going to keep it pointing at the x. And then negative 6. So you're basically just taking the negative 6 is greater than x and flipping it over to say x is less than negative 6, which is the same thing. So negative 6 will go in the middle of the number line, and then up to negative 5, up again to negative 4, and then down to negative 7, down to negative 8. X is less than negative 6, so I have an open circle on negative 6. And since x is less than, I need to go to the left, because as we go to the left, the numbers get smaller and smaller. And then same thing, the point on this inequality symbol matches the point on this arrow, but that only works when the variable's on the left side, because it doesn't match up with this inequality. It didn't match up until we flipped it, so the variable is on the left. And then for B, negative 7x is less than or equal to negative 35, so I have negative 7 being multiplied by the x. In order to undo multiplying by negative 7, I need to divide both sides by negative 7. So multiplying by negative 7 and dividing by negative 7 cancel out. So I'm just left with x. But because I'm dividing by a negative number, I need to flip this inequality symbol. So it was pointing to the left, and now it needs to point to the right. And then negative 35 divided by negative 7 is positive 5. Every single time that you multiply or divide an inequality by a negative, you have to flip the sign. So this went from less than or equal to greater than or equal to. So 5 will go in the middle of my number line, and then up to 6, 7, and then down to 4, 3. So x is greater than or equal to 5, so I have a closed dot on 5, and then since x can be greater than or equal to it, I need to go to the right because those are all the numbers that are greater than 5. And then for practice A and B, this is a good time to stop the video here and then practice and play the video when you're ready to check your answer. So you're going to solve and graph each inequality. So for practice A, it's x over 4 is greater than or equal to 9. So I have basically x divided by 4 is greater than or equal to 9. So if I want to get x by itself, I need to undo dividing by 4. So I need to multiply both sides by 4. So multiplying by 4 and dividing by 4 undo each other. I'm just left with x, and then I don't need to flip the sign because I just multiplied by a positive number, not a negative. So greater than or equal to stays the same, and then 9 times 4 is 36. So x is greater than or equal to 36. 36 goes in the middle of the number line, and then you can go up to 37, up to 38, down to 35, down to 34. X is greater than or equal to, so since it can be equal to, it needs to be a closed dot, and that x can be greater than 36, so I have to go to the right because that's all the numbers that are greater than 36. And then same thing, as long as my variables on the left side of my inequality, this point matches this point. So this is pointing to the right, and so is this. And then for B, 1 is greater than negative 1/10 x. So I have a negative 1/10 that's being multiplied by x. Usually to undo multiplication we divide, but because we have a fraction here that's being multiplied, in order to get rid of that fraction, we can multiply by the reciprocal. But here's where it gets a little bit tricky because we also want to figure out a way to kind of cancel out that negative. So I'm going to multiply by 10 over 1 by the reciprocal, but I need to multiply by negative 10 over 1 because I want this to become a positive x. And right now, if I just multiply this negative 1/10 by positive 1/10, I'll be left with a negative because a negative times a positive is still a negative. So I need to make the 10 over 1 negative, and then I'll multiply the left side by the same thing. So on the left, negative 10 over 1 times 1 is just negative 10 over 1 is the same thing as negative 10. So this is like negative 10 times 1, which is negative 10. And then with the inequality symbol, we multiplied by a negative number. So since we multiplied by a negative number, I have to flip my sign. So it goes from pointing to the right to pointing to the left. And then multiplying negative 1/10 by negative 10 over 1, those undo each other completely. So if I multiply by the reciprocal, those cancel each other out, and a negative times a negative is a positive, so I'm just left with positive x. And then the last thing I need to do is kind of flip this whole inequality over because the x is on the right and I want the x to be on the left. So I'm just going to mirror it. So the x will flip over to the left side. Originally the inequality was open to the x, so it's going to stay the same. And then negative 10. So we just took this one and we flipped it over, but the inequality stayed open to the x. So x is greater than negative 10. And then I can go ahead and graph it. So I'll have a negative 10 in the middle of my number line. And then up to negative 9, up to negative 8, down to negative 11, down to negative 12. So since x is greater than negative 10, it's not greater than or equal to, just greater than, it needs to be an open circle. And then pointing to the right, because that's all the numbers that are greater than negative 10. And then just a quick reminder, if you are deciding between an open circle or a closed dot, if you have a less than or greater than symbol, so not with the equal sign bar underneath, use an open circle. And then if you have less than or equal to or greater than or equal to, so with the line underneath saying it can be equal to, you want to use a closed dot.